Hi, I'm Ranger Rosa. Welcome to Yellowstone National Park and to the Old Faithful Geyser Basin. Behind me you can see Old Faithful steaming, and behind that you can see rolling hills blanketed with lodgepole pine trees and dotted with snow. We still have a lot of snow here in the interior, but it's a beautiful sunny day with a little bit of wind. Today we're going to be talking about the geysers of Yellowstone, and to do that will be Ranger Margot. Take it away, Ranger.
Thanks, Ranger Rosa. Hi, I'm Ranger Margot, and I am very excited to share with you about the geysers of Yellowstone. But of course, I want to recognize that Yellowstone National Park is a vast landscape. It's about 2.2 million acres and was set aside as the world's first national park in 1872. Now, Yellowstone was set aside because we have mountains and rivers and lakes and animals, but what it's most well known for, and perhaps one of the main reasons it was set aside, is because of our hydrothermal features, and especially our geysers. Now, in Yellowstone, we have about 2/3 of the world's hydrothermal features. That's about 10,000 features. And of that 10,000 features, we also have over half the world's geysers. There are about 900 geysers in the world, 500 of which are here in Yellowstone. Of that 500, of that 900, 150 are here in the upper geyser basin in this about 3-mile stretch. Of that 150, of that 500, of that 900, 50 are up on Geyser Hill right behind Old Faithful. That is the largest concentration of geysers in the world. But of course, most people think of one when they think of Yellowstone, Old Faithful. But all geysers here in Yellowstone have an important and special story to tell. But in order to understand their story, we need to understand a little bit more about the history of Yellowstone and its geology as well. Now, we have all of these hydrothermal features here in Yellowstone because we are on top of a what? A volcano. But not just any volcano, we are on top of one of the world's largest and most active super volcanoes, which means that it's really big. Now, the last time this supervolcano had a super eruption was about 640,000 years ago. It literally blew up the middle of mountain ranges and created a bowl or caldera 30 by 45 miles across. But we've had changes since then. When you come here, you don't just fall into a crater. We have it filled in with lava flows, like the ones that you see behind me. These are made up of rocks like rhyolite and basalt. This kind of brownish rock that I have in my hand is an example of rhyolite. It's a bit rough, and at times the basalt can create columns that you may see throughout the park. So this is when lava has cooled slowly, creating these hills throughout the park. At times, our lava flows can also cool quickly, creating rocks like obsidian. So this chunk of obsidian that I have shows that it's like volcanic glass, smooth, glossy, and this dark black color in this case. So we've had changes over the course of our geologic history. We've had glaciers come through and many natural phenomenons, but we have changes even going on here today. In fact, every day in Yellowstone is unique and special. Every eruption of a geyser, every moment that you spend here, you may see something unlike anyone ever has or ever will again. And I'm going to tell you a little bit more about why. Now, in Yellowstone, we have 4 types of hydrothermal features. We have fumaroles. Think of fumes rolling out of the ground, also known as steam vents. We have mud pots, which is where the sediment is broken down and redeposited in pot-like structures. We have our hot springs, 2 different types in fact. We have the Mammoth Hot Spring Terraces up in the north, where instead of rhyolite and basalt, the ground base is mostly limestone. So that water can actually change those rocks a lot quicker, creating the terrace structures that you see there. And we have our types of hot springs that are more in the interior with those rhyolite, basalt, and other types of rocks as their base. And so those overflow like you're overflowing your bathtub. And then, of course, we have our geysers. We have cone geysers like Old Faithful that you see behind me with that cone-like structure. And we have geysers like Grand Geyser, which is a fountain-style geyser. And it erupts out of a pool of water like fireworks in the water. Now, all of these kinds of hydrothermal features require a few key ingredients. So let's break down that word in order to discover a few of them. Hydro, meaning water, and thermal, meaning heat. you may be able to see some snow behind me. In fact, we can even get snow every month of the year here in Yellowstone. So that snow melt and the occasional rain that we get, some of it flows into our rivers, but a lot of it soaks into the ground, and it can be held in these rocks for days, up to hundreds of years, before making its way into the plumbing systems of these features for you to see. But while it's down below the earth, it's going through a journey. It's being superheated by a magma chamber that's anywhere from 3 to 8 miles or 5 to 13 kilometers below your feet, depending upon where you are in the park. Now, below that magma chamber is an even bigger magma chamber that's about 6 times larger, and it could fill the Grand Canyon in Arizona about 11 and a half times with magma. So we don't just have heat, we have a lot of heat. Remember, dun, 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 super volcano. So this area is a massive landscape. So we have our heat and we have our water. If you've ever boiled water on a stove, you know that you don't just pour the water onto the stove though, right? You need to put it in a pot, a plumbing system, a chamber system, something to hold all of this water. Now, not many people, when they worry about walking out their front doors, about falling into a hole that goes hundreds of feet into the ground. But here in Yellowstone, we do. So why is that? Well, the earth is constantly changing. In fact, we have 700 to 3,000 earthquakes every single year here in Yellowstone National Park. And while many of them are very small, they can have a big impact. In fact, if you were to tap your hands or your feet on a table or on the floor, someone a mile down the street may not be able to feel that, but someone sitting at your table probably would. So even though it's small, it can have a big impact, which is part of the reason that we ask, if you ever come to Yellowstone, please stay on the trails and boardwalks to help protect yourself and this changing ecosystem. Now, all of this shifting and shaping of the earth can help to open up these plumbing systems. And you'll notice that a lot of these features are in basins, concentrations. Instead of breaking through that thick rhyolite that we see behind me, it's going to break through more of the valleys where the rock is a little bit weaker and potentially closer to that heat source. So think about that when you're considering where these features may be. So we have our heat, we have our water, we have our plumbing, but just like in a boiling pot of water, that convection current is happening. So heat and pressure help to push that water back up out of these springs. So all 4 of these ingredients are needed for all of our types of hydrothermal features. But geysers are a little bit different. They need a little bit more. So if I were to take a plastic water bottle, take the cap off, empty it, and crush it, what happens to the air? It just goes out. But if I were to take a plastic water bottle, take the cap off, empty it, put the cap back on, and then twist and crush it, now what's going to happen? The pressure is going to build until finally that cap gives off, causing a type of eruption. Now, we can imagine these types of things. We can even see them when we're at the park or on our website or on our webcam. But you know what would be fun? Why don't we make one and see what happens there? So we're going to make a few different types of hydrothermal features here in our video. The first I'd like to show is a hot spring. So we have our plumbing system here. We have inside an antacid that I'm using today that's going to help create that illusion of a little bit of pressure and that convection. But we also have hot water. So let's see what happens when those are all added together. A hot spring! It's overflowing just like, say, your bathtub might if you were to let it keep flowing out. You can even hear a little bit of that interaction, just like you can if you were here in the park and would be able to hear those features. But of course, hot springs aren't our only feature that we can demonstrate. So let's see what might happen if we made a little bit of a constriction point. So we can see a little bit of what's happening here. We can try that just one more time. Occasionally, we need a little bit of extra pressure. There we go. And suddenly we may occasion, these geysers can have massive eruptions. You might have noticed that that constriction point was a little small. So what might happen if we have a geyser that gets so much pressure built up that it breaks its constriction point? This has happened before with features like Excelsior Geyser that used to be the largest geyser volume-wise until it blew its own constriction point from such a massive eruption. So let's see what happens when we add a little bit too much pressure. So we've got all the ingredients, we're adding hot water. It keeps popping the lid off. The lid just can't stay on and it keeps popping off, showing that sometimes it can even break its own constriction point. Now be careful if you do try this experiment at home. It can make a bit of a mess and we don't want any caps going flying. So make sure that you're in an open space where you can do this safely. So we've created the illusion of these types of features, but how do we know that this is how they work? Well, it's taken years of observation and studies. So what kinds of ways can we observe? One is physically with our eyes. We have dedicated volunteers and employees who watch these geysers day in and day out, evening and nighttime and throughout the days, in order to understand their characteristics and habits and in order to predict them. That's why we actually have 6 predictable geysers in Yellowstone National Park. So we can also understand them by adding some key components, understanding the flow. So when they erupt, they put out more runoff, and we can actually record that with certain instruments. In other places of the park, we have seismometers, like at Steamboat Geyser, because when it erupts, it creates such a massive shake in the earth that it sets off those seismometers in specific ways. Other ways that we can observe is through things that we see, big changes that we see over time. For instance, at Mammoth Hot Spring Terraces, unlike the rock that we have here, it can change really quickly. That limestone-based terrace, in the ideal conditions with water flowing over it for 12 months straight, could grow up to 5 feet or 1.5 meters in a year. Big changes can occur, like what happened on Geyser Hill back in September of 2018, when Ear Spring had a hydrothermal explosion. What that means is that instead of being the normal boiling hot spring that it is, it erupted water 30 to 40 feet in the air. And when that settled down and we went out, we found that it wasn't just water that came out of Ear Spring. We found coins and cans and testing equipment and a cinder block and even a pacifier from the 1930s. So we can see into the past, not just the present, but the past of these geysers and understand what's been going on in this ecosystem. Other ways that we've been observing, we do tests like temperature and pH, and we're doing an inventory of the thermal features in the national park. So when I say 10,000, that number could be updated at any given moment based on what we're finding. So it's an exciting time to be in Yellowstone. Things are always changing. In fact, even using some satellite imagery, we've found that an entirely new thermal basin popped up in one of our valleys of Yellowstone over the course of just 10 years. So with this new technology, people can get involved. In fact, you can get involved as well by watching videos like this and learning, and by looking at things like our webcams. We even have a webcam located on top of the Old Faithful Inn. So you can watch Old Faithful or any of the other geysers in the Upper Geyser Basin day in and day out, just like our dedicated volunteers and staff do. Now, when you do this, you might notice that every eruption is a little bit different and unique. But Old Faithful is perhaps the most famous geyser in the world. So more than just observing it, we wanted to study it a little deeper. So back in 1991, we had the great idea to stick a camera down it. Now, when we did that, we saw some insights to this feature. And at about 45 feet or 14 meters down, we were concerned about the timing between eruptions and weren't sure if this camera would start to malfunction or even maybe melt. So we brought it up before having to find out. But before that happened, at about 22 feet or 7 meters down, we found what makes a geyser work. Now we saw the difference between our hot spring and our geyser in our antacid experiment. but we also know what happens specifically for Old Faithful and some other geysers like it. Now, every time you watch Old Faithful erupt, you see it erupt for 1.5 to 5 minutes. Every time you watch it erupt, you see it erupt to an average height of 135 feet or 41 meters high. And every time you see Old Faithful erupt, you see 4,000 to 8,000 gallons or 15,000 to 30,000 liters or 50 to 100 full bathtubs of water coming out of that feature. All of that water, all of that pressure comes out of a constriction point about 4 1/8 inch or 10.5 centimeters around, about the size of your fists. So while Old Faithful is faithful, we do know that it can change. We actually track these eruptions, and so we say that on average, it erupts about every hour and a half. You can actually make these predictions yourself by watching an eruption of Old Faithful on our webcam in person or on our website. Now, when you do this, you just need to use a little bit of math in order to figure out when it might next erupt. Because we say that if it erupts for more than 3 minutes, it's called a long eruption. Now, about 95 to 98% of our eruptions are long eruptions, so it's a pretty good chance that's one that you'll see. And when this happens, more water is expelled, and we predict that about 94 minutes later, the next eruption will occur. Of course, we say plus or minus 10 because a geyser is still a natural event that can change little by little. If it erupts for less than 3 minutes, we call that a short eruption. Now, this is a little more rare to see, but it doesn't necessarily mean that you're going to miss out on height or anything like that. But you will notice that it takes less time for that chamber system to refill before another eruption can occur, before that pressure can build up like the water or the air in our water bottle. So when we have a short eruption, we actually predict that the next eruption would be only about 66 minutes later. But make sure to check the website or ask a ranger before trying to make these predictions, because these can also change over time. We're constantly tracking them in order to get just the right statistics to make it a good experience for all of our visitors and to understand these features a little bit more. So you can be involved in this as well. But Old Faithful can change. Now, it does change slowly over time. For instance, we ask you not to touch the water because it's hot. It contains mercury, arsenic, sulfur, bacteria. It can contain a lot of things that aren't great for you. But it also contains something called silica. Now, if I have salt water in my hand and the water evaporates, where's the salt? It's still in my hand. You're watching steam evaporate out of Old Faithful right now. And when it erupts, even more water starts to evaporate from that heat. As that water evaporates, silica precipitates out, building up a white rock that we call geyserite. Now, this whitish gray rock that you're seeing, it's a little bit rougher than, say, the obsidian we looked at earlier. It's got some holes in there that you might notice as it's built up, but this takes a long time to grow. In fact, unlike the mammoth terraces, that travertine that grows so quickly, geyserite on average only grows about 1/2 inch to 1 inch thick per century. So when you're watching Old Faithful, you're seeing it grow just very slowly. So we see these changes occurring over time, but we can even look into the past of Old Faithful. Now, occasionally we have really big earthquakes, and while even small ones can change some things, back in 1959 we had the Hebgen Lake earthquake that shook this area so much it created new features. It made features erupt that never had before, and it even extended the interval of Old Faithful by 20 to 30 minutes. So it is still faithful, but when people ask, is it not as faithful as it used to be? It's just changed. And these changes we see occurring all the time. In fact, looking far into the past of Old Faithful, we took some samples of the geyser cone itself. And inside we found trees dating back to 800 to 850 years ago, meaning that at one time, Old Faithful likely wasn't erupting the way it is today. Trees were allowing to grow, perhaps around a smaller feature or a dormant one. Perhaps like the other hills that you see around Old Faithful, but something changed. Water shifted and created the geyser that we know and love and all hope to see today. So these changes can happen quickly or over time, but remember that every single day in Yellowstone is a little bit unique and special. If you see an eruption, based on the time of day, the amount of water, the wind direction, where you're standing, and your own perspective, you're going to get something new and special out of this feature. Even just by watching this video, you might notice changes in the wind, in the steam, in the sunlight going on around me. And this is a very special day here in Yellowstone. And we have a unique opportunity because usually if you're here or watching a video, you are experiencing that in real time. But today we're capturing this moment in time. So you can refer back to this. You can see if you can notice some new changes. But by watching this and exploring more of what Yellowstone has to offer, you're part of Yellowstone's legacy. So we want you to continue to learn about this ecosystem, to try some new experiments, and hopefully come visit us or visit us again someday. So consider this. The water that you see evaporating out of Old Faithful, that could be flowing past your house in a couple of days. That could be raining on your house in a couple of weeks. It could even be in your coffee cup in a couple of years. So no matter where you are, the idea of a national park, the idea of preserving natural spaces, and even physically, Yellowstone is always with you. So thank you for wanting to learn a little bit more about Yellowstone and geysers here in Yellowstone National Park. And if you have a question, feel free to contact the park or ask a ranger the next time that you're here. Thanks so much, and I hope you had fun.